quickly walk you through what we're going to do. It will be a lot of fun, that I can promise, and I will try to see if we can have more time for questions and we can lead by question. But I will try to lay the uh, basic things out in the session. So today, what are we going to do? We're going to talk about agents 101. We will talk about one of the main thing that makes any LLM an agent, which is their workflows, or how can you add agents or tools to these agents. We'll double click on function calling and we'll see why it matters and where it comes along in the journey. And then we will also look at what are the main things or main building blocks of agentic workflows. And then I can quickly give you a lab run through where you can actually build end-to-end agentic applications using GPTs and also Vertex AI. Does that sound good? And then we can take questions. Dragos says good. That's all I need to care about. If you can turn your cameras on, it just helps me not to fall asleep because I have done this session many times. But it would be great if you can. If you can't, that's okay too. So join is here. That's all I care about. So thank you. Let's get started. So agents. First of all, I think agents are uh, agents are this way of us building on top of LLMs. So if you look at, let's go back in time in 2022, we got this amazing chatbots that allowed us to do so many things. It allowed us to actually get advices, solve problems, give unstructured data, get structured data back. And I think the killer use case was finding its problems and pasting it on Twitter. So all of you did that, and it was such a cool deal for all of us to grow and find something new. And one thing that chatbots did, that all 2022, when we started our first course, the top topics are, hey, how can I take my data securely to these? Because the offering was so compelling that people were taking their data to these applications. So Anthropic Claude was released then, ChatGPT, you have all seen, and Gemini came out. And if you wanted to do anything, you need to take your data to them. In 2023, things changed a lot. What happened is people said, okay, enough. How can I use this data inside my app? And you saw Notion releasing AI capabilities. Canva also has an AI app, which I can just show you. If I go to edit it, it can just say, hey, you can actually go and write it or design it with AI. Everything they allow you to magic write. So now I need not to go to those tools comes to me. So they will take my context from here and help me write this slide. So that's the Copilot experience. That's where Microsoft Copilot exists. That's where Amazon Q exists, which allows you to have your own data wherever it exists and bring the intelligence to the data. So first we try to take the data to intelligence. That was hard. We solved it with Copilots. We brought intelligence to where the data was. And now it was a right swipe in your Google Workspace. And it's a right swipe in pretty much every application. If it is not, it will be in next year or so. So that's where most of the people are iterating today. But this year, something more than copilots is catching and becoming mainstream, which is agents, which takes which uses your data, bring intelligence to your data, but also can take actions. Copilot, the challenge is that you are doing most of the work with the help of the AI. How about we empower AI to take actions on our behalf? And if they can take actions, they can actually take on tasks. And if they can take on tasks, then instead of offering software as a service, maybe we can offer service as a software or outcome as a service. We just discussed this today. We did pricing, and Kayuri and others in the cohort discussed or double clicked on this idea of how can we have jobs to be done as a service now. And this is what is possible with agents, because at agents, if you can take actions, you can take my job and do it for me. And if it is done well, then I have a price for that job and I can give you that. Copilot would ask you 200 questions and you can go back and forth and get the job done, but you need to be involved. The main difference with agents is that you can, or the promise that agents are making is that you need not to be involved. And we will see how true that promise is, and where you need to come in, where you need not to come in. So before we go any further, I just want to make sure that we all can understand the lay of land, because some people say it's a hype, some people say it's grounded. So where are we actually on that? uh, Landgraph did a awesome study or survey. So I just took the summary of that, and maybe we can just go through that. So if you look at this Langchain survey, it's done on 1,300 professionals, small, medium, large size companies. And three interesting things for me is, which we know and talk about all the time in our course or our in community. By the way, we have a community. I would love all of you to join the community. Karan paste the link to the community, where we meet every Saturday. We do these lightning sessions, but we also meet every Saturday to discuss and stay on top of AI ecosystem. So all of us are learning together and building together. So this is one of the sample, but we meet every Saturday. Please join the community if you can. So 50% of the people are saying, I have already deployed agents for my company. 78% are saying we will deploy it next year. So that's where you are. 50% of agents in these small, medium, large size enterprises are already getting adopted. What are the use cases? People are using it for research and summarization. They are using it to get personal assistance, which is, why don't you schedule my day? Why don't you get unnecessary meeting away from my day? Why can't you just go and take a contract and give me only the key terms that I need to look at, rather than giving me the whole contract every time a contract is sent to me as a lawyer? And of course, the killer use case, which is customer service and code generation. You have seen this all along. What else these agents are able to do? What are the concerns, or what kind of control do you have in place? So each technology also need to be binded. So they are saying observability and tracing is the first one control they are putting. Second, they are putting guardrails. Anybody? What are guardrails? Sorry, you came to learn from me, but I'd love to turn tables around.
Guide
Anyone? Go
guidelines
ahead.
around regulatory requirements, compliance requirements, and ethical requirements. Sort of like these components of responsible AI.
Great. What my friend Sham is saying is, the models can go wrong. You don't program. There is intelligence in them. And as we have guardrails in law, by saying you can't say this, you can't kick people, you can't do this, you can't do that. There is etiquettes guideline. Your company has your policy that you can't say bad things in a meeting. You can't abuse these people. Where are those for models? Putting those for models or machine learning or LLMs or large language models or your agents is guardrails. In this, you say what can it take as an input and what can it send as an input output. You're setting these boundaries, and those boundaries is this guardrails. Offline evaluation, you're checking every time, you're taking the data what your users or the jobs your agent took, and you are evaluating it with humans or automated evaluations. Online evaluation, you are doing it at live, and you are seeing that people are trying to observe. Most of them have gone to guardrails, most of them has human evaluation, and this is like online evaluation, which is mostly automatic, and you are seeing only 1 in 3 is there, which is a very good or good representation of what I have seen in market also. What kind of tools permission does your agent have? So what are you trusting it with? The next question. So thanks, Ankit. But read and write and delete with human approval. So people are still keeping humans in loop, 43%. And if you look at the interesting part for me is, if you say you want to write and delete and no human approval, only 1 in 10. So only 1 in 10 agents is given rights to do things on their own, because everybody is scared. And there is a reason for it, which is company size. This was interesting, but barriers. Reasons is their performance is so bad. Performance quality is the number one reason people are saying, Hey, that's why I'm not trusting it. That's why I'm only putting it on basic workloads like customer service, and I am doing software generation because there's a lot of data there for me to train. But anything beyond that is just hard. Cost. This is not cheap. There's a cost in it. We did a session on pricing today in our course, so you know what the cost is. And the cost is you pay X for building the service, you pay 10x for evaluating the service, and you pay another 10x for making sure that service is always available. Assuring customizing these models is very expensive, and also offering a TPM or request per minute or token per minute guarantees that you need to offer, that's very expensive. So if you put all those costs together, it's not a cheap endeavor for anyone. And that's the biggest barrier after performance. So people are ready, people want this. This tells me that a lot of people want agents, but performance is the main bottleneck. And after that, of course, cost. And then people are scared. And this is the not to surprise, especially people who have done the course. There's no surprises that latency. Anybody can tell me why these models take so much time? But we are saying mini models. The models are small. Everybody is saying I have such a small timeline. You can take my O1 mini, or you can take my flash model from Gemini. Why latency is such a concern coming up? Anyone raise your hand? This is a always, I know it's a lightning session, but we try to run it like a community. Ankit, go ahead. Good to see you.
Uh, Good to see you too. So first of all, we're doing a multi-agent way. So think of like the amount of calls it has to make. Like it's not like a chat GPT where you just question and you get an answer. You have to do reflection, memory. You need to go to different places. So that's why you are magnifying the latency across these multiple API calls that you're making. So that's why quality is such a massive pain point here, especially in the agentic
And
workflows.
and what about latency, Ankit? Why latency is such a, with LLMs? What is the challenge with latency or with agents? Let
Challenge
me
with
take it.
Sure.
Amit, go ahead. I know you took one, so let me give Amit a chance. Amit, go ahead. Amit, your raise hand, but I think you're mute. You're not mute. Okay, let me take it. So latency is what you, the models are great, but what happens is when you send them more context, and your when you build agentic specific workflow, you need to talk, as Ankit was talking about, you need to tell it a lot of instructions. What is your role? What job you can do? Hey, by the way, reflect on it and make sure that you have done the job. And then you have guardrails on top of it, that when you done the job, can you do all these checks? This is a lot of context, and you're giving whatever job is, you're also providing related documents for that. The more context you give, there is 4x more increment in time. This is a it quadruples, and there is a logic in attention, how self attention works. But for you today, the idea is that if you increase context by x, your timing to process it on the model size increases by 4x. So even if it is a flash model, even if it is a mini model, even if it is a model that people are claiming to be fast, the more context you add, the time is variable component. So if you send 10 words, it is going to take 1 second. And if you send 100 words, it's going to take 4 seconds, right? Because if you're going to make it 10x, then this is going to go up by 40 seconds, right? So that's the time variable. And who is ready to wait 40 seconds to wait for a call? We are so used to getting millisecond latency without GenAI or without LLMs. We're used to taking millisecond latency in our applications. So if that's the case, then you have this second challenge, which is latency, which is the last challenge is shown on the screen.
Mahesh, sorry to
Sorry,
interrupt you, but
Can
if you
you,
can stop, sorry,
yeah, stop sharing the
can you
screen?
stop presenting and show
that's
the
okay. I just realized it. So thank you. Thank you for making my day. But next time, I think we'll just move on this one. So this is all the interesting thing. These are the small, medium-sized enterprise companies. So now we know these are the main applications. So let's get back to our slides. So these are major takeaways. 52% have already deployed agentic workflows, research, personal assistance, customer service top scenarios, limitations, performance, cost, safety, latency. If anybody talks about why are you not using AI, and if you say any of these four, they will understand, and you will get bonus points. Even without doing anything, they will think that you know a lot about agents and AI. You have concerns. So, what are the key building blocks? So, we discussed earlier, if you joined late, we discussed how we have moved from chatbots to co-pilots, and now we are talking about agents. But if we are talking about agents, let's just quickly think about what does these agents, what makes an LLM an agent? What are the 6 things that makes an just from a chatbot specific or a large language model which you can send a prompt? Now I can. Now was the good time for me to get to board. We'll do a lot of things on the board. I just love doing board stuff. Marianne, thank you. Automation and memory. Great. So let's go. So we have, I send a prompt in English and it responds to me. This is common model. I want to make it an agent. And what things I need to add to it to make it an agent? There's 6 things which makes it an agent. Please type it in chat and the answers are coming as you're typing. Autonomy is agent behavior. To build autonomy, what you need to go and build in functionality is what we need to see. So one is role playing. Actions, somebody said actions. Role, good job. Role playing, actions, or I can say tools. I know you are saying asynchronous communication. Can I say cooperation or collaboration? Or async communication? Workflow. Workflow, baby. Guardrails. You have guardrails, and then you have memory. Anybody said anything? Education. And we have focus. So the problem with this approach is the simple approach of doing prompts and getting results is that tools and memory. Great. That's it. Let's just live with this 6 today and let's quickly touch on them and then we can talk more. Okay. So what is role playing? Role playing, you have seen it. We talk about these prompts all the time and we say, hey, assume to be this. As Sham was talking in our class, Sham is one of our cohort members, and he was explaining how he has broken a big job of building something in his company into smaller things. And then he's giving a lumbo sumbo job of saying, hey, why don't you go do research for me? Instead of that, he's saying, hey, here is a role for you. You are a research assistant. You are a checker. You are the guy who goes and find all the copies. You are the guy who goes and do analysis on these copies. So now he has 4 roles. So in your prompts, when you explain assume or pretend to be something, that's role playing. And these models, which are offering agentic workflows, are trained to do better when you give them roles. Okay. So make sure if you're building an agent, you are saying you are an expert doctor, you are an expert researcher, you are an expert this guy. Second is focus, or you can think of action or tools. So once I have the role, you can add actions. And today we will double click on this one. So I will cover it a lot in our section, how you add tools. But this is nothing, but you can call different APIs and get a job done, because APIs is how we have defined the world today. If you want to book a flight, it's an API. If you want to take money from your bank account, that's an API. If you transfer money from one account to another, that's an API. And the world is run by APIs. So how can you allow these models at runtime to choose these APIs? We will double click in it because this, my friends, is the most important things which made these chatbots into action taking agents. So I will double click on this one. So actions, tools, or something called function calling. We'll talk about this technical concept little bit in depth today. So you have all the capabilities, you know how it works. Cooperation, somebody said async communication. They need a way for each one of these agents to see what are the common tasks I can do and somebody else can do. And they need a way for you to explain it to them. Once they have get the roles and tasks, they need to see what the other party has done so they can pick up on each other work. So that's the cooperation part. Guardrails we already talked about. These are the limitations. And in the guardrails, the special thing which my friend Ankit was talking about is reflection. And the idea of reflection is nothing but what he's saying is that, hey, now you can reflect on your work, or you have other agent as a proxy agent. So if I go and I do the research, the other agent checks my work and says, hey, this work is not done correctly. You missed these 3 segments of reflection. Please go to these 3 websites also. You did not check it on Wikipedia, or you went to the Wikipedia, but you didn't check the sources. For these 3 things, you have not attached any sources. Please go and check it. So that's the reflection piece. And in the guardrails of an agent, you will find reflection. They have memory. Three kind of memory is becoming popular for agents. One is they have a short-term memory, where each agent, when they're talking to each other, they are putting things back. So in Sham's case, one guy went ahead and said, where should I do this research? He goes and updates the memory and says, these are the 5 sources I found out where we should go and do this research. The second, as soon as the memory is updated, the second agent goes and picks it up and says, let me scrap all the content on these 6 websites and put it again in the memory. So all that is stored in this short-term memory. Then they have some idea of long-term memory, where they store their interactions for future training. Also, if files are large, because memory needs to be small, if just the speed aspect. And then they can store these values on a larger file base and extract them on demand or when they need. And the third kind of memory, which is optional, is entity specific memory on where to focus. So they also do entity extraction from all the data and keep the things like who's connected to what, how they are connected. So in future, when one thing needs reasoning for other, they can go and get the entity specific memory. So imagine all you need to learn today is they have memory, and that memory is shared between these agents. On a multi-agent framework, if it is a single agent, which we will build today, all it carries is what you have told before, so that when you say, hey, remember my instructions, or apply the same thing again, then they are not reinventing. They're just doing the same thing. And whatever you have stored or told it before, they kept it in their short-term memory. And last thing is they have focus. This is the fundamental thing which was lacking in our previous model, that if you gave it too much instructions, it lost focus. It does not know what to do with what. Here, you keep divide and conquer, and you let each one of your agents focus on a very specific task, which can be measured by their own reflection, and you can put the right checks and right evaluation. So these 6 things, if you bring to large language model based chatbots, they can become agents. Ankit, go ahead.
I'm not sure if the topic for today is a little bit of around focus, like how easy it is to break it into multiple parts for it, like because it looks like a pretty hard problem to solve, especially thinking about like are we doing some kind of a chunking strategy here also, or like so because so many agents, how does everybody have a reflection? I think this is a hard one unless there's a easier way to do that kind
So
of a
a couple of
break.
things people are, so what Ankit is asking about is how can I put guardrails? And in specifically, the guardrail he's talking about is he's saying, how can I put a reflection specific guardrail? So reflection is nothing but if I tell it to do a job, let's say this is my agent, and I will just put a computer on it. So it's a computer specific agent. So this is not a human agent. This is a real computer agent. And now I tell it a job to do go research. research and find me 3 websites which I should read from. So now I wanted to focus only on getting what job it says. Do a research on agents and tell me top 3 websites. That's its job. And it has 3 weeks. It needs to come up with 3 websites. And reflection is then I have another agent which has checks that these 3 websites are relevant. And what Ankit is saying is, how can we do it at scale? What does it mean? So many reflection also needs to happen. So to answer that question, Ankit, what is happening is frameworks like AutoGen on Microsoft. Microsoft published an open source this AutoGen framework. And what it allows, this has an idea of a proxy agent. So every time you create an agent, they automatically create a proxy agent for you. So let's say you created this research agent, they create a proxy research agent for you. And what its job is, automatically it creates its own prompts, which helps you reflect. So every time this guy does a job, they automatically send it to this proxy agent, and this proxy agent goes and says, you have not done a good job. So there are frameworks which are thinking through this, like AutoGen, and most of the framework that you are seeing are basically building it part of the framework so that you need, as a developer or as a product manager who wants to build these tools with no code, can just go and deploy your research agent or this sub part of the research agent which finds website, and the proxy is created automatically. You can see what the checks are and modify it, but you need not to add them. Mohit, go ahead.
So who ensures that this proxy agent knows better?
Sorry.
So how do we ensure that this, or who ensures that this proxy agent knows better? Right?
Yeah, so that's a very good question, Mohit. Nobody ensures that, but now you, instead of just believing it, you have a way to check it, and you have a lever to improve its capability also. So yes, you made a very valid point that both of them are LLMs. One is doing the job, one is checking. It seems like, why can't I self-claim everything? They have different prompts and they have different guidelines, and you have a lever. So we will like AutoGen will create one for you, but then you have to come up and you can modify it with the checks. And same like you tell people, like people do the job, people check their work also, and you give them different instructions. That's what these agent or agentic firmware frameworks are allowing you to do.
Okay.
Sounds good?
Yep.
So like this quality assurance agent is what they are talking about. Okay, so now we understand the building blocks. One, if all of you have little appetite, I want to take you to this key building block. Vaibhav, can you park your question? Let's do this and then come to your question. I just want to get to 30 minutes. I want to get 10 minutes, and then you can ask me all the questions in last 20 minutes. This will be an hour-long session. So just give me 10 more minutes, and let's just quickly go through a critical aspect of this agentic workflows, which is how agents do function calling or how we add actions to them. Okay, so we discussed reflection, we discussed guardrails, we discussed focus, we discussed role playing. But one important, or I would say the most little complex to implement, is how you add tools to them. So this idea is that, hey, I can add tools, which is I can have function calling capabilities. So in a model, your application calls the API, the model detects and finds which function to call, returns it to your application, and then you can call that function. And if you can call that function can do the job. That job could be finding places nearby. So if I'm building a lead gen for a for solar panel detection, I need to know where I am. And now, as soon as the user comes in, I can extract their places. I can call the places API and find out where they are. And now I can give them something relevant. But how this model knows which functions to call, which function the user is asking for? So the flow is clear, right? You come up with a prompt, the LLM has all some information, and it tells you which functions to call. Your application calls the function, and then continues to do more and more. And this loop, when executes many times, actually allows you to do end-to-end automation of your jobs. And that automation makes these simple chatbots agents. But how how come this model knows which functions to call?
Are they also doing some prompt engineering?
Yes, means you will do prompt engineering, but it's also returning what parameters. The API responds your application specific function to call with the arguments to call with it. So it's not like, it is a little bit more sophisticated than that. Context, Amit, yes, context is good, but how I pass the context? Somebody said it, drag. As far as I see, OpenAI, your instructs the model which tools drag us, no, rag, no. We defined each agent. This is a fun session. Thank you for joining. All of you have so many ideas based on the rules. Platform, OpenAI, dogs, function calling. Yeah, you can read that, and
Role,
nobody can
goal, and the
understand it.
backstory. Because you're telling for every role, there is a goal and the backstory.
Mhm.
So the backstory it uses as a context, and the goal is what it does. Like suppose I'm telling this.
Yeah, but the goal requires you to have five things, right? At runtime, I have five APIs, and my company has 500 APIs, and I'm coming to you and I'm asking you for a question, and your job as a model provider is to tell me which function is relevant to this prompt or this context you gave me. How can I tell the model what APIs I have and define it? Mohit is searching on internet. While we do that,
Memory
we
in some
Ankit, go ahead.
memory that you're
Oh,
talking.
let Ankit go ahead. Ankit, raise the hand, right? If you raise the hand, you get priority. That's how this community works.
Don't pull my
Go ahead,
leg.
Ankit.
Okay, so the way NLP also works is, right, like you can, based on the input you're getting, you can do an intent of that function call, and based on that, you can decide which API to call. So that's what I'm thinking. Like it'd be using first principle, like, hey, if you're able to understand the intent, call that one. For example, if it's a weather related one, the classification is, hey, it's a weather related question, call the open weather or something like that. If it's related to a search, you call that. So that's how I'm envisioning it will look.
Ankit, you are 70% there. I just wanted to hear something very specific, and obviously, I wanted to hear it. It's something I set up, and obviously, all of you are not following what I wanted to hear. So, it's basically an open API schema. It's not open AI schema, open API
Okay.
schema that
Okay.
you provide. You have to provide that schema every time you add a function to your models. So you will, as you will see, as you add actions to these models, which I will show you live in a lab today, you have to add this whole schema. It's not black magic. You are telling it in this schema, what is my function doing? Instructions of the function, what the function does, what parameter it takes, what parameter it outputs, and in a very specific format. And the model is trained to understand this format and match your query with this JSON format and find the most proximity or the closest match in with this instruction to what you are asking it in your prompt. And once it finds it, it just looks for that and then says, these are the two parameters, and this is the function you should call. And you, as a developer, or your developers, when you go and say, now let's build agents with actions to your team, they have to go and write this open API schema. So make sure you are not thinking it's just black magic. You have to create all your APIs. You have APIs, but you don't have open API schemas of that. You need to go and create them. And once you provide them, that's how it works, which I will show you in a second. Once Janvi has a question, we'll take Janvi question, and then I will quickly show you how can you add this whole open API schema and build an end-to-end action-taking GPT first, and then I will show you Vertex. And that's all. Then you can ask me all the questions. Janvi, go ahead.
So my question was more to do with like when we do RAG, we chunk it and then we fetch the most relevant chunk and give it to the LLM, right? Why can't we do it in the same way where we find the most relevant function and we send it? Like why
But
is it not a black box?
yeah, so you are saying, hey, Mahesh, you have 500 functions in your company, and what you did is when you had a database of, let's say, contracts, 500 contracts, and you were asking a contract specific question in your model, what you did is you sent this to this guy and only extracted the contract which made sense, and then you added that question and then those contracts, and then you send it to the model and model gave back the relevant answer. This was your context specific to your question that you did in retrieval augmented generation, which is RAG. What Janvi is saying is, I can just put, instead of putting these contracts, I can just put 500 API calls as function. My developer called it sum, but it did minus. Who cares, right? People don't name their functions correctly. So here the list of all the functions or their documentation is here. And if I give it, it can tell me what function to call. Yes, Janvi, that can work. It's just not super accurate. If you add more details to it in a specific format, it allows the model to do its training. And if the model does the training, you want the most accurate API call to come back. If this API call has higher probability of failure, this agent which you're building will have randomization in calling these APIs. And if it has randomization in calling these APIs, your actions will be sometime taking weather information, or sometimes can go and start booking flights. Instead of LA, it will book it from SFO while you are sitting in LA. Because the first call it made is places API, but instead of making that call, it made the call for booking. And the context, somehow these names were similar. All it did is similarity search. But if you added the open API schema, then it knew what was the instructions, what was the input, what was the outputs. It has much richer details. And with richer details, it can do much richer mapping of these APIs.
Got it.
Janvi, does that make sense?
Yes, yes.
Little
And I
bit.
also liked what Ankit mentioned, that bar is much higher for agent versus for RAG chunk. So that's what you also.
See, Ankit can do it in one sentence. I have to write all this. Arman, can you hold your question? I just need to walk you through a couple of labs and then we can take questions.
Sure.
Okay, team. Thank you, Gaman. Good to see you. Long time. Okay, so I'm giving you 2 labs. Let me just walk you through those labs. The links are here, and let me make sure that you have access to this deck. Also, anyone with a link, right, can edit. No. Can comment. Copy link. All of you should have this link now. So in this, you can also follow along these labs. So these labs you can do. We do it in our class, but we love to give things for free. So here are 2 labs that allows you to build basic agents. This lab is a chat GPT lab. It shows you how can you, so we have this project in our course where we take contracts and try to find insights in the contracts. And this lab allows you to automate it like an agent. Let me just show you it in action. So if I go to my GPTs, maybe here. Oh, behind the scenes. Okay. So this is one of our labs. And this is what you can build, or the lab that we have shown. I will just show you how it works. So let's say you come here and you have your company has an Airtable, which is a CRM system. And what you want to do is you want to read all the contracts and take the key information out. This is what a human does today. It reads a 200-page contract and takes out who is the service provider, what is the customer name, contract date, contact details, and all. And you can keep adding fields here. But let's say you want to automate this. So all your AI should do is it should ask you for, hey, where is my contract? I signed a new contract today. I can go here. I can give it a contract. And that's it. And if I go and say done, I can also share this GPT with you. So you can just do the demo. See, I tested it before. So it's saying, you have already uploaded it. What the hell you are doing again? Yes. So it extracts these key terms from this contract. So that's the first GPT, which is mostly instructions. here. And then I created an action here, which I will show you in a second how I did that. And then it extract all these things and it says, should I proceed to save these details to the CRM again? I say yes. And then it goes and it will add an Excel. First, it will check with me because I put a check on security that before it's doing a right operation, I wanted to make sure it's doing the right thing. If I confirm, it starts the action. It says talking to your API table. And now it has taken for action for my behalf, where it called an API with these fields and inserted it right here as expel. Good. So now you have a chat GPT which take actions, and actions not only like what anybody in chat GPT can do, you actually customize it to take actions based on your company. And if you want to build something like this, you have to provide something called an open API schema, which I provided here, which is what is Airtable, what is my path, what are my keys, what this function do, what is the responses I can expect. And then I have to add my security keys, and then you can quickly test it also. And that's pretty much it. So now I would love all of you to go ahead and create your own GPTs with actions, not without actions. And if when you do it, just tag me or tag our community. I would love to say great job. With that said, let's quickly go back to our lab. So that's our lab number 1. I will not discuss the details here, but we have done a great job. I believe the team has done a great job of putting all the details here. It walks you through from the basics of how can you set up Airtable. Then it talks about how to create a GPT, which I just showed you. And then it tells you step by step how to make it successful. So please, please, please follow the instructions and get it ready. But this is a single agent GPT. Why can't I have a GPT which calls one agent to another? Because I also promised you multi-agent. Today we talked about multi-agent a lot. We talked about memory. We talked about reflection. We talked about focus. For that, there is another lab. That's our Vertex app. In this, we went into something different. We said, why not allow people to have car repairs? So it's a car repair agent, but it doesn't say I'm a car repair agent. It says I'm here to help anything with your cars. It has world knowledge. It has an tool attached to it, so it can find places. So we in this lab we show you how can you attach Google Places API, and then we have done integration to it. So if you ask it questions, then it can also generate leads for car repair companies so that they can reach out, or you can reach out, or they can do bookings for you. For that demo, it's also very simple. You can go to Vertex AI. Google gives you $300 in credit. So all you can do is you can go to your Google console, and there you can create multiple agents, and then you can call one agent inside another agent. So that's the magic of Agent Builder. This is a no-code tool inside Vertex AI, and it allows you to build agents like my car repair agent. And if you look at it, it looks like GPT, I know. But the beautiful part, which you can't do with GPT, can do here is, here I'm calling this tool. So I have attached these tools, but not only tools, I have attached another CRM agent to it. So I'm saying, hey, dude, here is an agent for you, right? So this guy, when I talk to it, will call Places Tools API, but when it needs to connect to CRM, it will call my CRM agent. So this agent will talk and call the other agent. So let's do that example. Let's say I say, hi. It says, how can I help you? I will say, what is the latest? I will say Toyota, but let's go Ferrari today. What is the latest Ferrari model? The latest Ferrari model is this. I need help to service my Ferrari. Can you help me find Ferrari service places in LA. Good. Okay. So you see that it took it, it automatically gave this API and called it. And now I am looking at Ferrari listeners. And then it says, hey, do you want us to connect you to them? So first it calls this tools automatically and find places, search these places near LA. I am in SFO, but I got places near LA. And now it says, hey, by the way, do you want me to connect you to them? Let's say I say yes. Then it says, hey, can you just tell me your name, your phone number? By the way, that's not my phone number, but you got the idea. And my address, which is Seaward Drive, Mountain View, CA 94043. If I say enter, it calls the other agent, which is the agent you have seen before, which is our CRM agent. And now it calls the Airtable APIs in that agent, and it inserts another key inside my lab. So this is our lab demo, but if you go to our Airtable, we have another database for Vertex car repair. And now you see my entries are here, which is what I just wrote. So now you're getting leads, and you can sell these leads to anybody who is interested. And now you have an end-to-end app which you can release to your people, your community, your lives. With that said, that's all I have to say. And we have 11 minutes for Q&A. So thank you, first of all. And rest is, I think Karan will kill me if I don't talk about, here is a course that I teach on Maven. I forgot to even put that slide, I believe. Yes. So here is a link to the course. The course will start in Feb. I think we are finishing our current cohort right now. And if you don't want to join the course, please join the community. The community is absolutely free. We meet every Saturday. We do discussions like this. People who were talking really awesome stuff in this call, like Janvi, Ankit, uh, uh, Sham, all these are part of the community. So please hang out with us on Saturday, and hopefully we all can go and become better at this new technology and apply it and change first our lives, and then our company's lives, and then our community's lives. With that note, that's all I need to share today. I will take any questions you have. Vaibhav, Dragos, Ankit. Ankit gets the last preference today. Vaibhav, you get.
Thank you.
Carmen,
Yeah.
Carmen, why don't Carmen go? Sorry, Vaibhav. Let Carmen go first because I know she's waiting for a while.
Okay.
Yeah, thank you. Sorry, I won't take that long, but when you mentioned to build the API, is that API built in-house from scratch, or you take like an open source API like LangChain, or how do you start with the API?
That's a very good question. So first, every provider, like in this case, in our example, Google offer you a places a how to find any place nearby as a maps API. So you can take the APIs which are provided as is. Then the second APIs is your company will have created some APIs, like this Airtable API that must already be there. You just need to bring it to LLM, and how you bring it by writing that open API schema. Third is you don't have an API. Carmen is saying, I don't have an API, Mahesh. So what should I do? Then you first have to create the APIs, Carmen, and then you have to connect it to your LLM. There is no shortcuts. The LLMs are not creating APIs for you. You can use them to write the code for the API also, but you have to first create the API, test it, and then your existing API can be connected. And you also have a lot of APIs, like everybody, like you talk to Salesforce, Google, Microsoft, everybody will be happy to give you an API which does the job which you do by their softwares. So there's an API in Word to open a document, to redline it. Carmen, did that answer your
Yes,
question?
thank you so much. Yes, it does.
Vaibhav, go ahead. Vaibhav is like, no, I'm not raising my hand again.
No worries, Mahesh. Absolutely fine. Just a quick question. Do we, in this multi-agent system, do we need to have like a main agent, like an orchestrator agent first, and then it will essentially act as like a decision-making body and kind of deploy everything or delegate the other tasks to other agents?
Yeah, so that's a very common practice. to have an orchestration agent, and that's like part of becoming this, what I was talking to Ankit earlier, that these frameworks like AutoGen. So everybody starts with an orchestrator whose job is to get the whole job done, and then it decides which agents to call when. Like in our case, when we did this Vertex example, our car agent was, or uh, our repair agent was the main agent, and it has the
Main
job
agent.
to call our CRM agent, right?
Got it.
And then this, if you add five more, then you can call this as an orchestrator agent. So
And
there will always be this one major party which takes user input and gets back to the user, but it's not absolutely necessary. It can be a round robin also. So
okay,
you just throw thing and then I take it, but somebody else writes the response. So orchestration is not the centralized response party.
got it, got it. And do we
And
need
and
to have
people call that an orchestration, yes.
okay, do we need to do any sort of like coding also like for configuring this, or this open APIs will do the job for us?
Yeah, so all coding you have to do is, if you're adding actions, you may or may need not to add actions, right? If you're doing web search, it comes out of box. If you're trying to write code, it comes out of box with these platforms mostly. So if you don't add APIs, you're not doing any coding. You can just define it in English as your prompts and it should work. Second is, if you're using other agentic frameworks, like if you're going to crew.ai, then they don't have a no code interface yet.
Mm-hmm.
They integrate with LangGraph, which may or may not work. And I've seen others, Langflow and all, they have their own challenges. But then you have to write simple Python code. The code is very simple, but you do have to write Python code to make
Got
this whole agentic work free if you don't go with GPTs or Vertex AI Agent Builder
got
or
it,
AWS Flows.
got it. Cool. Thank you so much, Mahesh. Appreciate it.
Dragos, go ahead. Dragos is going up and down in his hand, so I was like, give him attention. Dragos, you're mute somehow. See.
I'm having second thoughts whether I should be asking this question or not. But something that is puzzling me. You mentioned at the beginning that we're now moving into the space where you have outcome as a service, jobs to be done as a service. And I'm looking at what you're teaching people to do, you're teaching us to do, and it feels like, hey, you're teaching me to do job to be done, and I'll be able to do the same agent like you, and all the other people in this meeting will be able to do the same agent. And I'm thinking like, so how can I build a business around my agent? Because it feels like it's easily replicable, and it's like very hard for me to defend because everything that we need to know the customer owns the data, tooling is there, and it's rapidly progressing. All these practices are, I mean, a matter of time. People understand it. So how do you see the space of building businesses around agents?
That's a very good question. So, three questions in Drago's question. One is, seems like the cost of building or solving end-to-end problems is going down. So that's what he took it as a baseline. Second thing he seemed to say is that, hey, it seems like a lot of companies, tools builder have found their moat, like the cloud providers, that they are building more tools, like no code tools, which is even allowing product managers to build these end-to-end and deploy things. So they will make money. But if everybody can just go build things, where are we going to make money? So it's more like, so there are two things, Dragos, here. One is, there will be new things that you will see happen in our economy that were not possible because the cost of building things were so high. We only build things which are very, very generic. So you remember, like as a product manager, you're supposed to come with a persona and then say, what is the TAM of this? What is that? And what is that? Now you can target very small businesses, very small things like solar panel installation. Who's building a lead gen for them? And you can build it, and if it works in your community, then you can build the next one, then you can build the next one, and whoever built the first one will have a first mover advantage here. So that's one. So instead of generic apps, imagine more specific apps, and imagine more economy created out of that specificity, while generic things still continue to bring money to our economy, or more the current businesses stays, but their new businesses or new people are making money on building these small new things for this niche markets. So that's a new trend. Second trend you will see is, when you start building these things, actually providing this end-to-end value is not trivial. Putting all the checks, as you saw in the challenges, performance and guardrails, are blocking like 60 to 70% of deployment. And if you put cost and latency on top of it, this is not easy. Although getting started is easy, like building a website is easy, but building a very useful website which actually solves a customer problem is a very hard problem to solve even today. So you will see that some people will go ahead, will have domain knowledge, and will offer agents which actually get the job done. And most of the people will fail in this trajectory, where they will pick up these scenarios, they will have no clue how that domain works, and they will build something basic, and the basic website builder can feed their kids, but not the Facebooks are the people who actually went ahead and said, hey, seems like on internet there has to be a social network. Humanity need a new network. I'm going to build the new social network. That's the new world of agents, and some people will be very successful. And when they will be very successful are the people who understand their domains. But I don't see a world where there will be one Facebook. I see everybody will have their specialization, and in that specialization they will have a specialized agent, and that specialized agent will produce new economy segments for us, or new money for us, which is the bet pretty much everybody is taking. Dragos, did I answer your question, or at least took you much more closer? I know it was very open ended, so at least I
Yeah.
wanted to take you a little closer to that. So think about two angles. One is expect a lot of tools. Second, expect a lot of failure because the tech is not there. And third is, instead of single dominance, expect, at least for next 2 to 3 years, a lot of uh, polarity in dominance, at least with agents, and a lot of people taking things and trying to be successful, and some will be able to pass that phase and some will be left behind.
You give me a great starting point. I may follow up on your Slack community with follow-up questions.
Sounds
But
like a plan.
let's pass it on to someone else. Thank you.
Ankit,
Sure. This is
last
about.
question, by the way. I need to run. Go ahead, Ankit.
Sure. So you mentioned about the open API schema. So who creates it? I think the API providers have an open API schema, or
So OpenAPI schema existed before, Ankit, before
correct,
the
exactly.
LLMs even arrived to the scene. So when we were looking at like how can we improve the accuracy of this function calling, we were looking for one standard, and OpenAPI schema was that standard that existed, was already adapted by all the developer forums. So we landed on OpenAPI schema as a common thing. OpenAI took it. We were at AWS, we took it before them. So we built the agents with OpenAPI schema. I think they copied us, but who cares who copied who? Till the time there is one schema, I think we all are very happy.
Okay, great. Yeah, yeah, that makes it easier because I used to manage APIs before AI, so that's why I was like, okay, this is easy, straightforward. As long as so developers have to write that, or sometimes the API provider will have the open API schema already
So
available.
eventually, yeah, in the future, right? It's just 1 year till we made like OpenAI and AWS made it like, hey, we'll need OpenAPI schema. In future, I think like you have Swagger like tools, which allows you to give an API and generate your documentation. There will be tools which will take the API, creates this OpenAPI schema. They already exist.
Correct, yeah,
ChatGPT can write OpenAPI schema if you give them enough
exactly.
details, but still your dev needs to, because if you do bad OpenAPI schema, the format, this tool won't take it.
Got it. Yeah.
We have a check, right? GPTs have a check, Vertex has a check. So if there is any problem, it won't take it, and then you have to debug it. So that's the only development task left today.
Got it. Thank you.
With that said, it was an amazing session. You were an amazing audience. Thanks a lot. And I will see you on the other side in the community or the course. If I don't see you, I'm doing another lightning session where Madhumita from our cohort is coming, and she has built an awesome tool where she can check guardrails for agents. And she has built an agent which allows people to have fraud detection in marketplaces. So if you ever bought an Apple AirPod thinking it's cheap and later realize that it's fake, that's what she's ready to detect. And she will tell you 3 phases how she found the problem, how she built the first agent for it, and then when she went into accuracy, what challenges she felt, and then how she pivoted. It will be an amazing story, and we will build on what we talked today in that session. So please join that one if you like this one. I will see you next weekend or next weekend, I believe. Till that time, bye. Take care. Happy belated Thanksgiving.
Thanks,
you.
Bye, team.
Mahesh.
Thank you. Bye.